This is the homework video guide for the power rule, and for question number 1, I need to find the derivative of the following functions. All right, so for question number 1, I have y equals to 3, and so the derivative of constant is always going to be 0. And if you think about that on a graph, and if you have to graph the line y equals to 3, I mean, what's the slope of that line? Well, the slope of any horizontal line is always going to be 0. Okay, so that's how you do question number 1. And for question number 2, this is the same problem as question number 1. So instead of saying 3, we're giving you any constant. So the derivative of any constant is always going to be 0 because the slope of a horizontal line, as mentioned above, is always going to be 0, right? So I can change this to, a k, and you still have a horizontal line, and the slope of a horizontal line is 0. All right, question number 3. Now we can use the power rule here. So my power here is a 4. So 4 times negative 5 is going to be negative 20. And then I take my power and I subtract 1. So 4 minus 1 is going to be 3. And that's going to be equal to y prime. For question number 4, if I want to find the derivative, I start off by writing y prime. And I have a power of 6, so that's going to multiply onto the 3 over 2. So mathematically, that's the same thing as 6 times 3 over 2. And then the x variable remains, and then the power gets decreased by 1, so 6 minus 1 is going to be 5. And then after that, you just need to simplify this expression here. I like to divide, so 6 divided by 2 is 3, and then 3 times 3 is going to be 9, so 9x to the power of 5 as the final answer for that one there. All right, so for question number 5 here, you just need to change this radical into a power, so this will be x to the power of 2 divided by 3. So the index there, 3, is always on the denominator when you're converting that into a power. And then you can find the derivative by writing y prime. So the 2/3 gets soccer kick to the front. So that's going to be 2 over 3x. And then what we're going to do is we're minusing 1, right? So what I like to do is I always look at the denominator. If the denominator is a 3, then I subtract 3 over 3. So mathematically, you're just doing 2/3 minus 3 over 3, and that's going to be negative 1 over 3. So my power is negative 1/3. Now, although this is a correct answer here, you can definitely simplify this a little bit further here. You can write this as 2 over 3, and then this part right here, that's just the cube root on the denominator, right? So there's your final answer for that question there. For question number 6, let's rewrite this as a power. So 2 times, well, the square root of x is really x to the power of 1/2. And then let's go ahead and take the derivative, so y prime. All right, so 1/2 times 2. So 2 times 1/2 is going to be 1. So I'll just write the 1 for fun. And then x. And then we subtract 1 from the power, right? So the denominator is a 2, so I can subtract 2 over 2, right? So basically you're doing 1/2 minus 2 over 2, and that's going to be negative 1 over 2. So negative 1/2. And if you want, you can write this as, although this is a correct answer, you can also write this with a positive exponent. So this part right here, this is just the square root of x, but that's going to be on the denominator as root x. So there's another way to write question number 6. All right, question number 7, I would write question number 7 by taking this power and, that denominator, and writing that as a negative power there. So negative 2, and this will be x to the power of negative 3. And then it's very easy to apply the power rule here. So let's go ahead and find the derivative here. So y prime. So I take this negative 3 and multiply by the negative, it's a little bit off. You take the negative 3 and multiply with the negative 2. So negative 2 times negative 3 is going to be 6. And then we have an x here. And then we're just subtracting 1 for the power. So negative 3 minus 1 is going to be negative 4. Although this is a correct answer, I can leave the 6 on the numerator. And this part right here, you can just plot on the bottom as just x to the power of 4. Okay, question number 8. Let's go ahead and write this with the power here, so 2. And then this part right here, the radical on the denominator, you can write that as x to the power of negative 1/2. Right? And then as you take your derivative on your next step, which we do that by indicating that by writing y prime, then we take the negative 1/2 and multiply by the 2. So 2 times negative So 2 times negative 1/2 is going to be negative 1. And this will be x. And then we subtract another 1 here, right? So that's the same thing as subtracting 2 over 2. So negative 1/2 minus 2 over 2 is negative 3 over 2. And once again, that's an okay answer, but a better answer is maybe you can put the negative 1 on the numerator, and then on the denominator, you can park all of this on the denominator as, well, that's going to be the index of 2, square root, and x to the power of 3. Okay, so hopefully that's okay. That 3 is really that 3 right there, and this 2 is that index right there. All right, so any equivalent answer is totally acceptable for full marks. I think the back of the book actually just has the answer as negative 1 over x to the power 3 over 2, and that's totally fine as well. Okay, let's move on to the next few examples here. So find the derivative of the following functions. All right, so this is not too bad because we're given polynomials, so y prime. So power rule, 2 times 3 is going to be 6, so 6x minus. Now this part right here, I mean, the derivative of that is, I mean, that's just, you can think of that as the same thing as y equals mx plus b, right? So negative 5x plus 2. So what's the slope of that line? Well, it's just negative 5, right? So just write a negative 5 to finish off. And the derivative of a constant is going to be 0, right? So that's it for that one, 6x minus 5. For the next one here, y prime. Okay, we have the 2 here, so let's just bring that to the front. So that'll be 2x to the power of 1, and then divide that by the 3, plus, well, this part right here, you can write that as 1/2 x, and then if we add the 1, that's going to be plus 1, right? So what's the derivative of 1/2 x plus 1? Very similar to asking yourself, what's the slope of the line y equals to mx plus b? Well, the slope of that is just 1/2, right? So that right there is totally fine as a final answer. If you want, you can write the coefficient in front as 2/3 x, and then plus 1/2. Okay, let's move on to another one. Question 3. This one's not too bad. I believe this is a 4 here. Okay, so 4 times negative 3 is going to be negative 12, so 12x cubed plus, and then there's a 1/2 in front of the x, so that will be just 1/2, and that's going to be f prime of x. Okay, it's not too bad with that one there. Once you do a few of these, I'm pretty sure finding the derivative using the power rule isn't too bad. So this is minus 2. And instead of writing root x, we can write x to the power of 1/2. And let's go ahead and find the derivative. So y prime equals, all right, 3 times 5 is going to be 15. So 15x, and then if I subtract 1 from that, I get a 2. So 15x squared minus, and then we have the 1/2 times the 2 there. So 2 times 1/2 is going to be 1. So if you want to write the 1, you can, and then x. And then we subtract 1 here, which is the same thing as, you always look at the denominator and you always subtract the denominator, right? So the denominator on the top and bottom there. So 1/2 minus 2 is going to be negative 1 over 2. So this will be minus 1x to the power of negative 1 over 2. Totally fine to write your answer like that. A better answer would be 15x squared minus, then the 1 is there, divided by, and then this part right here, you can just park that on the denominator as just the square root of x. Okay. All right, so let's keep on moving on here. Okay, let's go ahead and maybe I'll rewrite this as 1 minus, I don't know, 1 over 15x plus, sure, maybe I'll write this as 1 over 15 x cubed minus 1 over 15 x to the 5. If you want, you can kind of simplify the original problem like that if you want to. There's different ways you can simplify it, but this is just one way you can do it. So let's go ahead and find the derivative now. Okay, the derivative of constant is 0. Okay, that's easy. And I have negative 1 over 15 times x. All right, so the derivative of that is just going to be 1 over 15. And then from here on, it's just the power rule here. So plus 3 over 15 x to the power of 2 minus, and then 1 times 5 is 5, so 5 over 15 x to the 4. And if you want, I guess it's good to take one extra line here just to simplify this. So 3 over 15 is going to be 1 over 5 x squared minus 1 over 3 x to the power of 4. And there's your final answer for number 5. Okay, let's take a look at question number 6 here. Once again, let's go ahead and rewrite this in a way that's derivative friendly here. So 1 over x is the same thing as x to the power of negative 1. And then plus, well, there's a 2 there, so 2. And then I have this x squared on the bottom, so that's x to the power of negative 2. All right, so there you go. We can now take the derivative. So the derivative of a constant here is 0. And then if I move over here, the negative 1 goes in front. So that's going to be negative 1 x to the power of negative 2. And then negative 2 times positive 2 is going to be negative 4x. And then by minus 1, I get a negative 3. All right, so there you go. Let's go ahead and simplify this. Here's my negative 1 in green divided by, and this part right here will go on the denominator as just an x squared. And then I have my minus 4, and then this part right here, that can really go on the denominator as just x cubed. So negative 1 over x squared minus 4 over x cubed is the final answer. Okay, so we move on to question number 7 here. 7 is not too bad. You just need to divide this 4 onto each term. So that's going to be x over 4 plus, and then we have this part right here, which is 2 over 4. All right, so if I want to take the derivative of that, y prime, sorry, maybe if you want, you can write that as 1 over 4x plus 1/2. But the slope of this line is just a quarter, right? So that's going to be 1 over 4. All right, so a lot of times you actually see the whole y equals mx plus b, right? And the derivative is just the slope, right? So that's nice. So that's another good way to remind yourself that derivative does mean slope. Okay, let's keep on going here. Question number 8 here. So I see a radical there, and I see an x on the denominator there. So let's go ahead and rewrite this as 2 times x to the power 1/2 plus 2 times x to the power negative 1. Okay, and then we can take the derivative by using the power rule here. So I have the 1/2. So 1/2 times 2 is going to be 1. And then we have an x there. And if I subtract 1 from the power here, that's the same thing as minusing 2 over 2. So 1/2 minus 2 over 2 is going to be negative 1/2. And then I have a plus. Let's start out a plus. Now I have a negative 1 multiplying on the positive 2. So that's going to be a negative 2. X to the power of minus 1, and then negative 2 there. Okay, let's see if we can simplify this. There's the 1 here, and then this part right here, that gets parked on the denominator as 1 over root x. Okay, and then I have my minus 2 in green, and then this part right here, that gets parked on the denominator as 1 as over x squared, right? So there it is, 1 over root x minus 2 over x squared. Okay, let's move on to letter G here, and right away I see denominators there where we need to kind of rearrange those or rewrite those. So 3 is the numerator, and that's going to be x to the power of negative 2/3. Okay, so we can rewrite that radical into a power, and then I can do the same thing over here. So minus 2, and then that's going to be well, there's an index of 2 here, right? So that's really going to be x to the power of negative 3 over 2. Okay, and then I have g of x over here. Okay, so we do have to spend a little bit of time kind of rewriting that problem there in terms of a power, and now we can use the power rule. So this is going to be g prime of x equals 2. All right, so now we're going to do a little bit of math in our heads here, right? So right away, the calculation that we're doing, I'll do this on the side here. We're really actually doing the math of 3 times negative 2/3. So the 3's cancel off, and you get negative 2, right? So that's going to be negative 2x. All right, and the next calculation that you have to do is you have negative 2/3, right? The power is negative 2/3, and you need to subtract 1 from that. So that's the same thing as minusing 3 over 3, which equals to negative 5 over 3. All right, so the power negative 5 over 3. Okay, so those are some of the calculations that you have to do in this particular problem. The next step is you take the power of negative 3 over 2, and you're actually multiplying that with negative 2, right? So that's really the same thing as negative 2 times negative 3 over 2 the negative signs cancel, the 2's cancel, and you should get just 3, right? So that will be positive 3x. And then finally, you just need to subtract 2 over 2 here, right? So that will be negative 5 over 2. Okay, so I actually think that's an okay answer to have. I believe the back of the book just leaves it as negative 2 over, and then they just have x to the, sorry, the back of the book just has 5 over 3 there, and then plus 3 over, and then we have x to the power of 5 over 2. So I won't change it to a radical. You can, but since the, actually, yeah, let's go ahead and just change it to a radical just for extra practice, right? So this would be cube root of x to the 5 plus 3 over, that is 2 square root of x to the 5. All right, so that's another way of how you can write that particular answer there. Okay, but I believe this answer is totally fine as well. Okay, let's go on. Let's do a few more questions here, and let's see how we're doing with the power rule here. I will say the next 5 examples that I'll do to I will do to complete this video guide has to do with some algebra steps here. So there's a lot of these grade 9 algebra steps here. So I have 3x to the 4 divided by x cubed. So the way you would write that is 3x to the 4 divided by x cubed, and then you create another fraction as 2x squared divided by x cubed minus 1 over x cubed, right? And then after that, I would keep on simplifying this. So this would be 3x plus 2, and then over here, if I do 2 minus 3 is negative 1, so that's really 2x to the power negative 1, and then minus, and then I would just change that to a negative power, so that's x to the power negative 3. All right, now it's ready to take now you're in ready mode to take the derivative here, so let's go ahead. The derivative of 3x is going to be 3. The derivative of the next term is going to be negative 2x to the negative 2, and then negative 3 times that negative sign is going to be positive 3x, and then subtract 1, which gives you negative 4. Okay, and this is an okay answer, and if you want to just write this with positive powers, you can for extra practice. And then I'll have x to the power 4 there. Okay. All right, so these kind of next few questions are designed for you to do a little bit of algebra work at the beginning, and then you can kind of simplify things. Question number 2, yeah, things kind of get a little annoying here, but let's go ahead and see if we can rearrange this, so or rewrite this. So I have 2x cubed, and that's really being divided by root x, and root x is the same thing as x to the power of 1/2, right? Plus, then I have my 3x times root x, and then that's being divided by, I could write x to the power 1/2, right? We know root x is equal to x to the power 1/2. That's why I kind of wrote that there. But for this middle term, I'm just going to write it as just root x. And the last term, there's a minus 1, and I'll divide that by x to the power 1/2. Okay, so notice that I kind of kept this term and this last term as x to the power 1/2, and then in the middle term I just left a root x and a root x, just because on my next line I can easily cancel that out, right? So next line I can cancel that out, and if I keep on simplifying here, I have y equals to 2. Now take a look at this part here, x cubed divided by x to the 1/2. So if you have to do a side calculation, we're really doing this, x cubed divided by x to the 1/2, which is the same thing as x to the power of 3 minus 1/2. So think about this logically, right? It's like $3 minus 50 cents, which is 2.5, right? And 2.5 is really 5 over 2. All right, so that's another way to write that. So this is 2x to the power of 5 over 2. Okay, and then if I keep on going here, I get positive 3x. And then if I have to change this fraction here, that'll be negative x to the power of negative 1/2. And then after this, I do feel like we're a little bit ready to take the derivative now, because everything's written in nice power here. So here we go, y equals, all right, I have 5 over 2 times 2, right? So the 2's will cancel, and you should get a single 5, x to the power of, and then we can subtract 2 over 2. So 5 minus 2 is going to be 3, so 3 over 2 is the power there. and then plus 3, and then the negative 1/2 multiplies with that, which gives you positive 1/2 x, and then we can minus another 2 over 2, which gives us negative 3 over 2 here. Okay, so that's a totally fine answer there. If you want to go ahead, we can write this as a radical 2 just for extra practice. So index is 2, x to the 3, plus 3, plus 1 over 2. So this 1 is that, and this 2 is going to be that 2 there. And I would say that this part here in green, we're going to park that on the denominator there as the index of 2, and then x to the power of 3. All right, so that's how you would do that particular question if you want to rewrite everything as a radical there. But I do believe this line is totally okay for full marks. Okay, let's do a few other ones here. So, okay, let's just kind of rewrite this into, let's try to do this a bit quickly here. All right, so same kind of technique from the first 2 problems in this section. We kind of split up into a big fraction. All right, so now do the math in your head. I have a negative 3 minus a negative 2, right? So negative 3 minus 2. So negative 3 minus negative 2 is going to be negative 3 plus 2, right? So that's going to be 3x, and that's going to be to the power of negative 1 plus 2, and then I have this part right here, right? So that's the same thing as negative 1 minus negative 2. So negative 1 plus 2 is going to be positive 1. So that's going to be 2x to the power of 1. And then this part over here, if you actually flip this, this is actually minus x to the power of positive 2. All right, so a lot of weird negative powers on that particular one. So make sure you can reciprocate things and subtract a negative number from another negative number so that you can get your powers done correctly there. So y prime. Okay, so negative 1 times 3 is going to be negative 3. So negative 3x, and then minus 1, so it'll be negative 2, right? All right, next one here, 1 times 2 is going to be positive 2. So 2x, and then we minus 1 from that, so it'll be 2x to the power of 0. And then finally, this 2 can come over here, so minus 2x there to finish that one off. And let's go ahead and rewrite this into a nicer, using nice numbers here. So that here can go in the bottom as x squared. That's going to be, now this right here is just 1, right? Anything to the power of 0 is 1, so 2 times 1 is 2, and then minus 2x. Okay, so there you go for that particular question. That was a weird one, and I guess we have 2 more kind of questions to kind of finish up before we finish off this homework video here. All right, so these ones are a little bit annoying because you really have to be good at adding fractions here. So basically, we need to distribute. We need to take this and we need to distribute that onto the brackets, right? One thing that you have to do is, one of the first calculations that you have to do is 6x to the power 2 over 3, and you're going to multiply that with 2x. Okay, so how does that work? Well, you multiply the numbers with the numbers, so 6 times 2 is going to be 12. So that's how you get your 12. And then you have to multiply x to the power 2/3 times a single x, right? Well, that single x really has like an invisible 1 there, right? And that invisible 1 is the same thing as 3 over 3, right? And then what you do now is you just add the powers, right? So 2/3 plus 3 over 3 is going to be 5/3. So this will be x to the power of 5/3. Okay, minus. Now the next step is a little bit easier because you're just taking 6x to the power 2/3 times negative 1, which is going to be 6x to the power 2/3. So that's kind of step number 1. I'm just going to write down y over here. I don't want to write f of x. I'll write y just to save a little bit of time. And now we can take the derivative here, right? And now we still have quite a bit of work to do because now we're going to multiply 5/3 by 12, right? So the math is 12 times 5 over 3. I like to do division first. So 12 divided by 3 is 4, and 4 times 5 is going to be 20. So that'll be 20x. And then we need to subtract 1, which is the same thing as minusing 3 over 3. And that's going to be that's going to be positive 2/3. and then we take our 2/3 and we multiply that by 6. So that's the same thing as 6 times 2/3. If you want, I like to do division first. So 6 divided by 3 is going to be 2, and 2 times 2 is going to be 4. So minus 4x, and then I can subtract 1, which is the same thing as minusing 3 over 3. So that's going to be negative 1/3. And I'm going to leave it like that. I don't want to simplify this because there's quite a bit of brain power already involved in this question, and I just don't want to do any more work for that problem. But that's it for question number 4. Okay, let's take a look at question number 5 here. This will be the last one for this first video here. So f of x equals, this one right here you should write as a power, so that's x to the power of 3 over 2, and then bracket x minus 3x squared. Alright, so now you're going to take this x to the power of 3 over 2, and then you're going to distribute that onto here and there. Okay, so if we do the math here, I'll do this a long way here, so that's x times x to the power of 3 over 2 times by an x. Now the x really has an invisible 1, right? And that invisible 1 is the same thing as 3 over 3. And then minus, if I keep on distributing, I get x to the power of 3 over 2 times 3x squared. Okay. All right, let's go ahead and do this now. So if I'm multiplying this, if I'm multiplying with the same bases, that's the same thing as adding the powers. So 3 over 2 plus 3 over 3 minus, okay, how can we simplify this next part? Well, there's a 3 there, so let me park that 3 in front. And then I have x to the power 2/3, so x to the power 3 over 2, and then multiplying that by x squared. Okay. Now, instead of writing the x squared here, I know I'm going to add the powers eventually, so I'm going to erase that 2, and I will write that as 4 over 2, because 4 over 2 really is 2, right? And once again, if you are multiplying with the same bases, you're just adding the powers. So now I can just add the powers there, right? And get rid of that x. Alright, now we're ready to kind of continue simplifying here. So this will now be x to the power of, okay, I'm not sure why I did 3 over 3. I do apologize. I think that's better to write that as 2 over 2, right? So 2 over 2. And that way the denominators are the same. So I apologize for that. I think 2 over 2 would be better. Okay, so 3 over 2 plus 2 over 2 is now 5 over 2 minus 3x, and if I add that now, that's going to be 7 over 2, I believe. Good. Alright, so that's f of x equals 2, and now let's take the derivative after all that work. Okay, power rule, so the 5 over 2 comes in front, x, and then if I subtract 2 over 2, that's going to be x to the power of 3 over 2 minus, alright, 3 times 7 over 2. I don't think we can really do anything with that, can we? Nope, so 3 times 7 is going to be 21 over 2. And I have my x here, and then let's subtract 2 over 2, which is going to be 7 minus 2 is going to be 5, so 5 over 2. Okay, so that's it for this particular question. I think where I kind of botched it was this part right here, that 2 over 2. I had 3 over 3 originally, but it should really be 2 over 2 to kind of help with the math there. Okay, so that concludes this homework video guide on the power rule, and we'll see you next time.